An electric field of intensity 4.50 kN per coulomb is applied along the x-axis. Calculate the electric flux through a rectangular plane 0.450 meter wide and 0.900 meter long. If the plane is parallel to the YZ plane, if the plane is parallel to the XY plane, and if the plane contains the y-axis and its normal makes an angle of 40 degrees with the x-axis. So the question is asking us for each part to calculate the electric flux, and so why don't we look at the equation for electric flux below. So the equation is electric flux equals to electric field times area of the surface cosine theta. Now, the angle will be between the electric field direction and the direction of what is called an area vector. And so, we'll have to take a closer look at what these two vectors actually mean. So, why don't we actually draw the scenario that's described in part A? So, here we have our traditional y-axis and x-axis. And then we have this third axis that we typically don't deal with in this course. But it does occasionally come up, and that is known as the z-axis. And the question notes that the electric field is applied along the x-axis. So why don't we draw an electric field vector that's pointing in the same direction as the x-axis? And then for part A, we're going to attempt to draw a rectangular plane that is parallel to the YZ plane. And so the YZ plane would be this region right here. And if we were to draw a rectangular plane that is parallel, that we would basically draw another rectangle that is sort of a carbon copy of the one we drew earlier. And with that rectangular plane, we can draw what is known as an area vector. And an area vector will always point perpendicular to the rectangular plane. So, we would draw a vector that's sort of projecting in this manner right here. What you want to ask yourself is, what is the angle between this area vector and the electric field vector that we had drawn just a moment ago? And hopefully we can see that the angle between these two vectors is actually 0 degree. So for part A, we're going to be plugging in 0 degree for theta, and we have the electric field given to us.